Hey class, welcome to Chapter 4, Organic Waste Management. Those of you who are astute observers will notice I'm on campus right now in front of the environment buildings, and that's because right behind me over here are two rotary drum composters that are part of the on-campus composting system. These are a small example of some of the technology we can use to degrade organic waste in a way that is better than just putting it in the landfill. But if you're looking at them and thinking, well, campus is really big, those are really small, you're absolutely right. Organic waste is still not very well diverted in Canada. Going back to our previous unit, we should probably be not wasting it in the first place, but there's a lot better uses for it than throwing it in the landfill, where it's just going to make landfill gas, which is a greenhouse gas and has other risks as well. So it's a huge resource. About 40% of our waste is organics. So if we can reduce it, or that part we can't reduce, treat it in a better way, there's a lot we can do in terms of energy, in terms of making a circular economy with respect to the soil and our food systems. And it's also a really good way to engage people in the waste system and teach them about the inherent value in things. If you've ever been part of like a community composting or a community gardening effort, you really see that circular economy happening that you don't necessarily in like the blue box, where we just set it and forget it, put it on the curb, and we don't really understand the system. So people understand compost a little bit better. But it's still something that we have a very long way to go on. So we'll get into that in this unit, how compost systems as well as anaerobic digestion work, what are some of their benefits, the promise that they hold for this huge fraction of waste that is organics, and also some of the reasons we haven't seen it growing as much yet, some of those technical and non-technical barriers to actually implementing this technology.
So to get started on this topic, we'll look at three streams of waste that are accepted at organic waste treatment facilities. Firstly is our municipal source separated organics, or SSO. This is the stuff that we put in our green bin, our food scraps and table scraps, and there's a big range of contamination we might find in this material. Some municipalities really focus on getting consumers to put a nice clean SSO stream at the curb. So in region of Waterloo, we're sending our stuff mostly to the compost facility in Guelph. They don't have a lot of capacity to remove contamination, so we really stress only putting things that should go in, using compostable or paper liners and things like that. In City of Toronto, they have a different approach. They really just want to encourage participation and make it easy to use. So they allow you to use shopping bags and include a lot more items like diapers, for example. So a little bit of a different approach, and that changes what the facility downstream will have to look like. Leaf and yard waste is another one. So depending on the time of year, this could be twigs, grass, leaves, Christmas trees, pumpkins, stuff like that. And so there's a big variation throughout the year, and it's also a lot drier than the food waste. That's a key kind of physical parameter of it. And then lastly is our institutional, commercial, and industrial waste. And there's a huge range that falls under this umbrella. So if it's coming from like a food processing facility, it could just be like peels and cores or off-spec bulk product, really, really clean. Or it could be like packaged food in cans on a cardboard flat wrapped in shrink wrap, and they'll send that to facilities that can handle it as well. It could be from restaurants, hospitals, all sorts of places. So a characteristic of food waste is that it's very wet, and this can cause odor problems because it goes anaerobic quickly, and also can leach highly odorous and hazardous in other ways leachate out, which has to be controlled. And it's a reason that people cite for not wanting to have source separated organic collection. Inclusion of soiled paper is a way to kind of counteract this moisture to it. And like I mentioned, there's a whole range of contamination. On the left, you can see kind of a post-consumer waste, so something that we put out at our own curb, and that has the potential for getting all sorts of materials that don't belong in based on how well we know our system. And then on the right is what we might call a pre-consumer waste. So this might be coming from a food processor or a restaurant, and it could be cleaner, it could not be cleaner. Again, just to stress, food waste is a really silly problem. You can see in the picture just a colossal amount of food being wasted. To put it into numbers, 1/3 of all the food grown is wasted. If food waste were a country, it'd be the third largest country. 28% of the world's agricultural land produces wasted food, and Canada spends 31 billion on wasted food, about 1.7% of our GDP per year. So just a colossal waste. So we shouldn't have to be building these facilities, but we are, because we haven't solved all these problems yet. A lot of that is due to what's happening out of our control on the supply chain side, but consumers are responsible for almost half of that waste as well. So there's a valid criticism in kind of environmental sustainability that a focus on personal actions distracts from larger systemic focuses, and looking at what corporations and governments who really punch with a lot of weight can do. With food waste, that is definitely also true. We do need better policies and better performance from companies, but a lot of it is from our own actions as well. So a lot we can do to reduce having to have these facilities. Leaf and yard waste, as I mentioned, is highly seasonal. So based on what time of year it is, people are doing different kind of landscaping things, and you could get all sorts of stuff. So it could be like branches and pieces of trunks that might not make it through a process. It could be grass, which is pretty biodegradable. All sorts of stuff could be in there. There's different rules on what you can put in based on the municipalities, but kind of that variability in the material and throughout the year makes it a little bit of a curveball to deal with the leaf and yard waste. Leaf and yard waste also really easy to reduce. So grass cycling is a policy of leaving lawn clippings on the lawn. There's a bunch of benefits to the lawn to actually leaving them there, and we don't have to create this waste stream from doing it. A lot of places actually ban grass from the yard waste collection. So going back to some of our methods for waste reduction from chapter 2, bans might apply here. For leaves, there's also just the practice of not raking your leaves. Leaves are actually really important habitat for a lot of pollinators and amphibians and important animals. And when we rake them up, it destroys a lot of that habitat and creates this extra waste stream. So another thing that we could do to not produce this waste that has other co-benefits. So a lot we can do on both the food and the leaf and yard waste to prevent us having to deal with it. But alas, we still have a lot of it. We can't get rid of all of it. And organics are really a real asset. They're a liability in a landfill, but if we can divert them, then they're a real asset. And that's because the organic portion is the portion that's going to break down and form landfill gas in the landfill. It's going to form high strength leachate that's acidic, and it's going to leach metals out of our waste. And if we can take that out and only bury inert material, our landfills would be a lot safer. If we can get the organics out, we can have better energy recovery from them. We can save space in landfills. We can recycle nutrients back to the soil and improve the soil in all these other ways. So there's a lot of really positive things about keeping the organics out of the landfill. Reducing in the first place would still be better, but keeping out of the landfill is way, way better than putting them in the landfill. Thinking about the linear and the circular economies, so one of the really important reasons to compost or use anaerobic digestion is to keep our nutrients in a natural cycle. When we have a linear system where we actually go and like mine certain minerals, like potash, for example, to make fertilizers, and then we use them, and then our waste, if we throw it in the landfill, we're losing those minerals from the system. If we want to be more like nature, we need to find ways to cycle them, and using compost or AD is a really good way to do that. In the picture on the slide here, you can see one of these guano islands that was exploited in like the 19th, 18th century when they were really wanting to do high intensive agriculture. And so this is bird guano that's deposited over like hundreds and hundreds of years, and it's like multiple stories thick, right? But there's this whole scramble to take over islands in the ocean to control this resource. And that's because there's certain minerals, so potassium and phosphorus, that we have to mine. Nitrogen we can fix from the atmosphere if we spend a lot of energy doing it, but potassium and phosphorus we have to take from the earth. So the more we can recycle them with organic waste practices, then the less mining we have to do. And there's all kinds of co-benefits to not doing mining. And there's a really great episode of the podcast 99% Invisible about the Guano Islands part of history. So I'll post that. It's a really good one. It's a really good podcast.